Okay, so one of the interesting things about polar coordinates is that you can actually have different coordinates that actually represent the same exact point. This is not something that we can do in the Cartesian plane. If you're given x comma y, let's say 5 comma negative 7, there's only one way to represent that point as 5 comma negative 7. But with polars, there is more than one way to represent the point. So let's go back and look at the point that we plotted, 2 comma pi over 3. Which was right here. So another way to represent this same exact point is if we hadn't rotated positive pi over 3. If we'd gone in the other direction, the coterminal angle here would have been negative 5 pi over 3, and we still would have been positive 2 units, right, from the point. So this would be another way to represent the same exact point. So even though you're getting there a different way, you're still arriving at the same destination. There are also other points that you can represent using a negative r value. So when r is negative, it means you go in the opposite direction. So if positive 2, right, is in this direction, right, negative 2 would be in this direction. So we'd want to be at an angle here and have a negative 2 as our value. So if we looked at that, so negative 2 pi over 3. So negative 2 pi over 3 would bring us here. And then because r is negative, we go in the opposite direction, which would, again, arrive at the same point. And same thing if you used a positive theta value to get to this angle, that would be positive 4 pi over 3. And then again, negative 2 means you go in the opposite direction of the angle. All right. When I say opposite direction, it means 180 degrees or pi radians in the opposite direction. So these 4 coordinates all represent the same exact point. And technically, there's an infinite number of ways to represent the point, since we can keep finding coterminal angles as we go through. Now, when we're doing conversions between rectangular and polar coordinates, we use a lot of the basic trigonometry that we already know. Okay, so looking at our point, that was r comma theta. If we set up a right triangle, we could see the rectangular coordinates x comma y would be represented by these two distances, where r would be this distance and now theta is this angle. So we know a lot about this triangle. All right. In terms of Pythagorean theorem, we could state that x squared plus y squared has to equal r squared, since this is a right triangle. All right. So we know that this would have to be true. All right. If we knew the rectangular coordinates, we could find the polar coordinates this way, or vice versa. And then in terms of trigonometry, using theta, we could set up some of our trig ratios in a right triangle. So in this triangle, sine of theta would equal opposite over hypotenuse, so y over r. Cosine of theta would equal adjacent over hypotenuse, x over r. And tan of theta would equal opposite over adjacent, which would be y over x. So if we rework some of these equations, we can get our conversions from polar to rectangular or rectangular to polar. All right, so our coordinate conversion. These 4 conversions, all right, come from that last side that we just looked at. So when you have cosine of theta equals x over r, to get x by itself, we would just multiply r over, and we would get x equals r times cosine theta. And over here, to get y by itself, we would multiply by r, and we'd get y equals r sine theta. So this is the conversion we use when we're given r and theta, and we want to find x and y. So basically, this would be our polar to rectangular conversion. Rectangular to polar is a little trickier, but we would use these 2 equations. So we have the r squared equals x squared plus y squared from our Pythagorean theorem. And then we also know that tan of theta equals y over x. So if we wanted to get theta by itself, we could take the inverse tan of both sides, and we're left with theta equals inverse tan of y over x. So these are the 2 that we would use if we were going from rectangular coordinates, x comma y, to polar coordinates, r comma theta. So we're going to do those in the next examples on the last video.